Hello, this is Jeremy, Ritwick, and Jerry from Mrs. Bailey's Math Analysis BC math class, and today we will be teaching you guys a little bit about conics. So the first conic, and the most basic one of them, is the circle. The circle is the locus of points equidistant from a given point known as the center. I'm going to show you what that means. Here's a circle. That is the center HK, and this is R. And then, you can't really see it, but all the points on a perfect circle are equidistant from that center. So all the points on that circle are equidistant from the center. So, the standard equation for the circle would be x minus h squared plus y minus k squared equals r squared, where h and k are the coordinates of the center and r is the radius. So now let's do some example problems involving this circle. So one of them would be, if this is the equation of the circle, what is the area of that circle? So the first thing to do would be to complete the square like so. Now we condense them to get x plus 2 squared plus y plus 1 squared equals 16. Alright, so now that we have that standard form equation, we know that r squared equals 16, r equals 4, using the formula a equals pi r squared, you would get a equals 16 pi. So another example problem we can do is, this equation here represents a circle, and the question asks, what is the greatest possible integer value of a? So we follow the same process and we complete the square like this. Again, 2a divided by 2 is a, squared is a squared. There. So again, we condense these and we get x plus a squared, hold on a minute, x plus a squared plus y minus 2 squared equals negative a squared plus 4, because in the original equation we moved over the 2a squared to make equals negative 2a squared and then added a squared and 4 to that. So then we know that r squared equals negative a squared plus 4. R squared, since it's the radius, must be greater than 0. So therefore, negative a squared plus 4 greater than 0. A plus 2, a minus 2 greater than 0. And then the values of a that would satisfy, or rather, should be less than 0. This should be less than 0. So, my bad. Okay. So the values that satisfy that are negative 1 is less than a is less than 2. So the question asks, what is the greatest possible integer value of a? And 2 would make the radius 0, so therefore we would need 1 would be the largest possible integer value of a to make that an actual circle. So one more problem about the circle. This equation here, x squared plus y squared minus 6y equals 16, is a circle, and the question asks, what is the circumference? So you know r squared equals, just kidding. First we have to complete the square. And it's always the first step when you have an equation in general form. So, upon doing that, you get x squared plus y minus 3 squared equals 25. So therefore, you know that r squared equals 25, and therefore r equals 5, so therefore the diameter equals 10, and therefore the circumference would equal 10 pi. Yeah, we just use the formula circumference equals pi times the diameter. Then the diameter is twice the radius, so the circumference would be 10 pi. So another conic section we have, which is similar to the circle but not exactly the same, is the ellipse. The ellipse is the set of all points x, y in a plane, the sum of whose distances from two fixed points, otherwise known as foci, is constant. So we have a couple of equations to represent an ellipse. H and k again represent the center, just like the circle. X minus h squared over a squared plus y minus k squared over b squared equals 1, and x minus h squared over b squared plus y minus k squared over a squared equals 1. The difference between them is that since a is always greater than b, the top equation represents an ellipse with a horizontal major axis, and the major axis is the length from one vertice to the other in an ellipse. And the bottom one would show an ellipse with a vertical major axis, so they're a little bit different. So again, the length of the major axis would be 2a, the length of the minor axis is 2b, and then if we have c, which is the length from a center to a focus, c squared equals a squared minus b squared. Here's kind of what I was saying. So here's our ellipse with the horizontal major axis. So A is, again, the distance from the center to the vertex, represented by B. B is the length from the center to a covertex, and then C is the length from the center to a focus, and then we get, this represents A as well, so that's how you know that C squared equals A squared minus B squared, just by the Pythagorean theorem. Alright, so some example ellipse practices. Have an equation here of our ellipse, x squared plus 4y squared minus 6x plus 8y plus 9 equals 0. So, and if we want to know what the center of this ellipse is, we have to complete the square just like we did with this circle. So first thing, when you complete the square, you put the constants on one side and the variable on the other. Oops, that's squared. Just kidding, that's actually a 2. My bad. Make sure you know how to do division, and then this is 1. Sorry about that. Okay. So, when you condense them, you get x minus 3 squared plus y plus 1 squared, or 4 times y plus 1 squared equals 1. To put that into standard form, you would take the 1/4 out and put it on the bottom. Okay. So then, since the center is h comma k in x minus h and y minus k, we know the center is 3, -1. Alright, so one more. If we have an ellipse like this, x squared over 5 plus y squared over 27 equals 1. Question asks, what is the length of the major axis of this ellipse? So, we know that since a is greater than b, and the equation shows a squared and b squared, we know that a squared equals 27, b squared equals 5. So then you know that a is square root of 27, or 3 root 3. And the length of the major axis, as I said before, is 2a, which equals 6 root 3. So then you know major axis equals 6 root 3.
Okay, so now we're going to go on to parabolas. A parabola is a set of all points in a plane that are equal distance from a fixed line, their directrix, and the fixed point, the focus. So the standard form of equation with vertex at x at origin 0, 0 is for vertical axis. X squared equals 4py. Alright, so p is the distance from the vertex to the focus. Alright, so we're going to show you some graphs. These are two parabolas with the vertical axis. This is the parabola. This is the focus at 0p. And this is the directrix, which is equal to y equals -p. And p is greater than 0 in this case. We also can have a parabola like this, where it's inverted over the horizontal axis, and p has to be less than 0 for this case, and the directrix, which is this on here, is equal to y equals p. And this is the focus, Okay, so the standard equations of a parabola with the vertex at hk are as follows. So for vertical axis, it is this. X minus h squared equals 4p y minus k. And for a horizontal axis, it is y minus k squared equals 4p x minus h. So for a horizontal axis, the equation would be y squared equals 4px. Again, p is the distance from the directrix to the focus. And to put this in perspective, I drew some graphs. So for the one on the left, this is the parabola. This is the directrix. Equation for the directrix for this case would be x equals -p. And this is when p is greater than 0. when p is less than 0, we can see the parabola is inverted over the vertical axis. And the directrix for this would be x equals p. Now let's move on to some examples. Alright, for this problem, the question asks, what are the focus and directrix of the parabola whose equation is given by y equals 1 over 16 x squared. So how we're going to solve this is we're going to rewrite this first. So we can say x squared equals 16y. So I just multiplied both sides by 16 and 16 to get this. Now we can just take the 4 out, so we can say x squared equals 4y. And since we know the focus is at 0, 4, then the directrix has to be at y equals negative 4. Alright, so for the next one. So for this question, it asks, find the focus of the parabola given the equation down below. So how would we approach this? So we would first write this in standard form, which would be y minus 1/4 equals negative 1/4 x squared plus 4x. Now we would use completing the square to get this. Y minus 5/4 equals negative 1/4 x plus 2 squared. We can now also rewrite this to become x plus 2 squared equals 4 negative 1 y minus 5/4. Therefore, the focus, which is at h, k plus p, would be equal to negative 2, 5/4 minus 1, which would also be equal to negative 2, 1/4. Okay, so now we can move on to hyperbolas. So a hyperbola is defined as a set of points in a plane, the difference of whose distances from the two distinct foci is a constant. So the standard form of the equation with a center at 0, 0 for a transverse axis which is horizontal would be x squared over a squared minus y squared over b squared equals 1. The picture would be for this. The hyperbola would be on the horizontal axis, and we would have foci here, negative c0 and at c0. Okay, so the lines here are the asymptotes, and from A here, we can say this line here is A, the height here is B. So C would be here, and we can derive this as c squared equals a squared plus b squared, where the focus, this stuff here, is plus minus c0. Another equation would be for the transverse axis when it is vertical, and it would be y squared over a squared minus x squared over b squared equals 1. A picture for this would be like this. So we would have our hyperbolas on the vertical axis, asymptotes here. Our c would be, instead of plus minus c0, it would be 0 plus minus c, because it's vertical now. Alright. Our a would still be from here, from this guy here, and b would be this. Again, we could derive a focus or c from c squared equals a squared plus b squared. Now to find the asymptotes of a horizontal axis, we would do y equals plus minus b over ax. And this is for the horizontal again. For the vertical axis, we would use y equals plus minus a over b x. So the standard equations of a hyperbola with the center at hk for the horizontal transverse axis, which is horizontal, would be x minus h squared over a squared minus y minus k squared over b squared equals 1. Where again hk is the center. Y minus k squared over a squared minus x minus h squared over b squared equals 1 would be when the transverse axis is vertical. Okay, so for the first problem, it asks, if the equation of a hyperbola is given as x squared over 25 minus y squared over 16 equals 1, what's the equation of its asymptotes? So we can see from this, we can use the equation for the asymptotes, y equals plus minus b over ax. We know this is a vertical, the transverse axis is vertical since a is greater than b. And we can also know a equals 5 and b equals 4 from this. Since the asymptotes we know from, so we can derive the asymptote now, since we know b and a from here, which is a squared and b squared. So the equation of the asymptotes for this would be y equals plus minus 4 over 5x. So the next problem asks, the equation of a hyperbola is defined as y equals 9x squared minus y squared minus 36x minus 6y plus 18. And we have to find the center. So to start this problem out, we would rewrite this as 9x squared minus 4x, we would complete the square now, plus 4 minus y squared plus 6y plus 9 equals negative 18 plus 36 minus 9. So we can rewrite this as 9x minus 2 squared plus y plus 3 squared equals 9. X minus 2 squared minus y plus 3 squared would be 9 equals 1. And we did this by dividing 9 on both sides, so 9, 9, 9 here. So from this, we would find the center to be at 2, negative 3, as x minus 2 squared minus y plus 3 squared over 9 equals 1. So we found the center from here and here. This is h and k.
Hi, this is Ritwick. I got the hardest part, rotating conic sections. The formula for rotating conics, the general form, is ax squared plus bxy plus cy squared plus dx plus ey plus f. Very long. And another equation for basically helping you rotate axes to eliminate the xy term can be defined as cotangent of 2 theta equal to a minus c over b. The primed form can also be obtained by x being equal to x prime cosine theta minus y prime sine theta. Y is equal to x prime sine theta minus plus y prime cosine theta. So those are the main equations to help rotate axes. There are also some other little tricks that can also help you out which classifies rotated conics. For example, the discriminant plays a major role. So if the b squared minus 4ac in the general form is less than 0, you know it is an ellipse or a circle. Okay. Now, if the discriminant is less than 0, if it is equal to 0, the b squared minus 4ac, then we know it is a parabola. Now, if it is greater than 0, we know it is a hyperbola, which Jerry discussed. Jerry discussed both hyperbola and parabola, so you should already know those. Okay, so now that we've learned all those equations and little tricks, we can start practicing some main problems. Okay, so the first problem we'll practice is quite simple. It is just xy minus 1 is equal to 0. And if you remember our long equation of ax squared plus bxy plus cy squared plus dx plus ey plus f, in this equation we only have two terms. We have the b term and the f term. So we should start off with our first equation. Actually, we should start off by classifying what type of conic it is. So we can use our discriminant, which is b squared minus 4ac. So as I said, there is no ac actually, so it's just b squared. And since there's the 1 is the coefficient in front of xy, we know that the discriminant is equal to 1. And if you remember, 1 is greater than 0, which means this will be a hyperbola. So we already know what type of conic this is. Now our next step is to find the theta. And if we use our equation of cotangent 2 theta is equal to a minus c over b, we can easily find theta. So again, we don't have a or c in this problem, so it'll be 0 over 1, which is also equal to 0. So cotangent 2 theta is equal to 0. And remember, cotangent is cosine 2 theta over sine 2 theta, and we know it equals 0 only at 90 degrees. So 2 theta is equal to 90 degrees, which means theta is equal to 45 degrees. That means the x prime and y prime axis is tilted 45 degrees. And now that we have the angle, we can use our next equation, which is x equal to x prime cosine theta minus y prime sine theta, and the other one for y, to find out our primed form of x and y. So we know is x is equal to x prime cosine 45 minus y prime sine 45. Sorry for the handwriting. Then we can easily simplify this down to x is equal to x prime over root 2 minus y prime over root 2. And now we can also do the same thing for y. The formula for y is x sine 45, x prime sine 45, plus y prime cosine 45. Now this simplifies down to x prime root 2 plus y prime root 2. So that was step 2. Now we move on to step 3, where we substitute our original equation to obtain the prime equation. So remember, our original equation was xy minus 1 is equal to 0. Now we just found the x and the y, so we substitute. So x prime over root 2 minus y prime over root 2 times the y, which is x prime over root 2 plus y prime over root 2 minus 1 equal to 0. So now we have to basically FOIL. Okay, so now that we have this, we can FOIL this into, you can do the FOILing yourself, but the final answer is x prime squared over 2 minus y prime squared over 2 is equal to 1. So we will be using this equation to find all our key points and graph. So we know a is equal to root 2 because that was the denominator under x prime, and b is also equal to root 2. And we know the axes have been tilted 45 degrees. So we can start drawing our graph. This is the regular x and y axis, and we can start drawing our primed axes. That's 45 and that's 45. And we know that since it's root 2, we can easily go, it's going to be between 1 and 2, so we can go there, and we can draw a hyperbola. It's just general drawing, not exact, and write root 2 down here. It will look like this. This is what xy minus 1 equals. And we have asymptote at plus or minus 1 x prime. Okay, so those will be that go like that. That's our asymptote. The one that, it's just like a regular hyperbola, but obviously tilted. So this is the graph for the problem xy minus 1. Now we will be moving on to a more challenging problem. And this is 7x squared minus 6 root 3 xy plus 13y squared minus 16 is equal to 0. So first we find out what type of conic this is. So we do our discriminant, which is b squared, which is 108 minus 4ac, where ac is equal to 91. And without calculating, you can already tell that 4 times 91 is less than 108, so it will be negative. So we know it's 0. So it's going to be an ellipse. Okay, then we have to find our angle. So cotangent to theta is equal to a minus c over b. We just plug in a minus c over b into the formula, and we get 1/2 over root 3 over 2. And again, cotangent is cosine 2 theta over sine 2 theta, and that means 2 theta is equal to 60 degrees, and theta is equal to 30 degrees. So the primed axes are tilted 30 degrees. Our next step is to find the primed form of x and y. So we know by using the equations, x prime cosine 30 degrees minus y prime sine 30 degrees, that's equal to x. We also know y is equal to x prime sine 30 degrees plus y prime cosine 30 degrees. So we know that for y. That simplifies down to x root 3 over 2, x prime root 3 over 2 minus y prime over 2. Y is equal to x prime over 2 plus y prime root 3 over 2. Now we plug this into our regular long equation. Gets kind of tiresome, but to finish the problem we have to do that. So 7 x prime root 3 over 2 minus y prime over 2 squared minus 6 root 3 x prime root 3 over 2 minus y prime 2, it's very long to go into the second line, times x prime 2 plus y root 3 over 2 plus 13 times x prime 2 plus y prime root 2 over 2. So you basically, the equations we got for x and y with the x prime and y prime, we just plugged that into a regular equation, and now this is all equal to 16. And now this, the hardest part, is actually to FOIL. So hopefully all of you know how to FOIL, so you just FOIL that out, and at the end you get x prime over 4, x prime squared over 4 plus y prime squared 1 is equal to 1. So if you ignore the prime notations, this looks like a regular ellipse formula. But we know that the graph, new slide, we know the graph, the axes are tilted 30 degrees. So it'll be a little less than 45. Again, this is a general overview. So those are the primed axes. Let's not forget to label them. X prime, y prime. And we know that from our last equation, a is equal to 2 and b is equal to 1. So if we go up 2 here, that's 2, 1, 2. Now b is equal to 1, so we go 1 this way, 1 this way, and we can actually start drawing our ellipse. So that is the graph, a general graph of the ellipse. Thank you so much for watching. Again, this has been Ritwick, Jeremy, and Jerry, and we have presented you the conics chapter of math analysis. Bye-bye.